This video is going to be really long and probably pretty boring and tedious for most people. However, it was just so cool to have Kevtris, Kevin Horton, in my house. And most of this video is working on the M82, reverse engineering that main chip that couldn't figure out how it worked or whatever. I'm really regretful that I didn't record like the first 30 or 40 minutes of him being here, because we had so many excellent conversations about so many things, and every time I was like, man, I wish I was recording that. But my intentions were to just record the M82 stuff, you know, because I wasn't real sure about how he felt about, you know, me putting him on camera or some of the stuff we said being heard on camera or out in the public or whatever. So, you know, towards the end of the night when he's getting ready to leave, he's like, yeah, let's make some more videos. I'm like, sweet. So hopefully we'll touch on some of those topics at a later date. Definitely will be making a second or third video about findings on this video, and you'll see that towards the end. And I'll talk about his emails to me and stuff like that. But let's get through this real quick.
What I was going to do, I was going to try and figure out how this was hooked up. Oh, it's all put together.
I can take it apart.
Do you have a close-up picture of what that board looked like? Do you know what chips were on it?
It's only 5 screws.
Oh, okay. Oh, I see. They all go to that ASIC there, don't they? Yeah, that's definitely a Nintendo-made ASIC right there. So it's not a microcontroller, unfortunately, like I thought it was.
Crushing everybody's dreams right now.
What do people want it to not reset?
The time limit is a problem. 128 minutes.
Yeah. Who plays NES more than 2 hours?
Well, I don't know that you ever would, but you don't want to.
Yeah, you're in the middle of playing a
or,
game, and then all of a sudden it's like.
Forget about it.
Yeah.
I'd love to have a timer, like an actual clock.
Oh,
Counting down up here, just so you can be sure.
Don't lose those. Oh, okay, so there's 7447s and 27475. Those are latches. Yep. Okay. Huh. So, they send up... Huh, that's interesting. Yeah, this can show all the way up to 99. Huh. Yeah, this can't be doing very much. Yeah, this can't be doing very much at all. You have Google up.
Yep.
Go to the GISM, search for GIICM. GIICM. No E. And 1 C. Yes, there you go. First link. No, that's it. That's right. Go to 7450 to 99. 7400 series TTL ICs. Up. Yeah. 7475. Alright. So that's a dual 2-bit transparent latch complementary output. I knew that's what that was. So 4 and 13 should be connected together, I would assume. And it is. Those are the latch enables. Let's probably go down to the ASIC of Doom. No, they don't. Really. I'm just trying to kind of get an idea of what they are actually doing. Right there, right there. Okay. So, I heard it beep. Oh, there it is. Okay. Those are the latch enables for the displays.
Looks like 17, 18. Or 1819.
1819, mm-hmm. So I'm guessing. You know, they have all these latches if they got this ASIC on here. Maybe they're just trying to make it mysterious. Because basically what could be done, you can make a little adapter board that replaces this with a microcontroller on it. Yeah. And it could take the place of that, and you could do all sorts of things, like if you wanted to reset the system, you could hold this select button down for like a second or whatever. So that's one.
Now you're talking.
Now that's one possibility. And you could make it still act stock if you wanted, but I don't think it'd be that hard to really do that. But what I was curious about is, yeah, this chip here. It's probably using one of RCA's little 4-bit micros. What this reminds me of is their lockout chip clone on the Tengen cartridges.
Oh yeah.
That they were made by RCA, and granted it's a 16-pin chip and this is a 40, but it very well could use a similar core inside it because it has a 4-bit CPU in it. That's how we ended up reverse engineering the lockout chip, and that's how I made the clone, is using the info game from, actually we peeled the chip and photographed it, and I drew the schematic of the chip out.
Who peeled it?
Loopy did, actually. I think he's the one that had it peeled and imaged. I'm not sure, it's been...
He had it done.
Yeah.
You don't know who did it?
I'm not sure who did it.
I was curious.
Yeah.
What that cost.
I don't know how much it cost. It was done more as a favor instead of actual... for hire.
Right.
So it was like a kind of a team effort. Someone had it peeled, and then Loopy figured out what all the blocks did and which blocks were which, and then I drew a schematic out of the chip, and then we figured out how the op codes for the CPU from there. Because we figured out how the CPU worked. It was a very, very simple CPU. You could hardly call it a CPU. It was really simple. And then, so I made a clone on the PIC micro using the algorithm. I didn't use any of the original code or anything, of course. Just the algorithm for it. So, Actually, this is where the notebook comes in handy. So it looks like the brains of selecting games is actually done in this chip. So I think I noticed on your video when you turn it on, it sequences through all the games really fast, doesn't it? Looking for valid cartridges.
Yeah, because it'll skip right past those flash cards.
Oh, it actually skips past the flash cards?
Until they're fully booted.
Really? That's interesting. So like the power pack, it'll just skip right by it? Wonder why. And the other problem with this system probably will not work with MMC5 games.
Probably not.
The reason being is they map registers in at 5,000 hex, and I don't think this properly can handle that. So...
What's well, even Abadox don't work.
What?
Abadox doesn't even work.
Abadox doesn't work? That's MMC3, isn't it?
check.
I think that's MMC3. That uses interrupts, so it won't work. If it uses MMC3, the chances are it will not work on this.
MMC1.
MMC1, and it doesn't work. That's very surprising, actually. Oh yeah, reverse engineering the Game Gear cartridges that have EEPROMs to save your games on them. Because I've been working on Master System Game Gear on the FPGA, getting the accuracy up, because the accuracy is only 96% or something right now. So I want to get it to 100, of course. So games with EEPROMs don't work, and there's only just a couple. So I figured that was a nice, easy thing to get fixed. So they come to find out they have a little custom baby ASIC to do that on there. And I have a Game Gear dev board, and it's like this big. And so when you stick it in the Game Gear, it looks really ridiculous. It's literally this big. It sticks out. It's like twice as. It's like the size of a Game Gear.
I think I've seen that thing.
Oh, have you seen that?
Where have I seen that?
I don't know. It's made by Sega. Made it, so maybe there's
maybe
pictures.
I have seen pictures on the
maybe
internet.
there's pictures on the internet of it. Yeah. Yeah, this is how I do it. Very low tech, but it works. So just write down what pins do. So
I know 40, 39, 38, 37
are the switch. So basically, latch enable was pin 4. And we know that went to what, 19 was it? 19. What digit is that? Thanks. 330 ohms. That is is this the front of the board? Is this how it sits? Or,
Yeah,
oh, it sits on, oh, it's upside down. Okay, so that's the tens digit. What was it, 19?
Wait, I might be backwards. No, that's right.
18. Yeah, because the big part has to go over here. Oops. Yeah, so that's some kind of custom micro. I don't know. I don't know why Nintendo would have had a custom chip fabbed for this instead of just going with a standard 8048, 8051 micro. Doesn't make any sense. You know, that must have cost a lot of money to have that made.
There was a guy on Nintendo Age, and his ID's Ferris Bueller.
Okay.
He said he bought one from a guy whose dad helped design it.
Oh, really?
But I emailed him and I said, did he help design the electronics or did he help design the kiosk?
Uh-huh.
You know, because...
Yeah, the mechanical design versus electrical.
Yeah. I never heard back from him.
I'm guessing this is designed in Japan. You know, Nintendo probably wouldn't farm out the electronics.
That's kind of what I was thinking. I was like, you may design something, but it's probably just the thing that said it.
I can tell you right now that Nintendo designed that circuit board. Just looking at the parts they used on it. I'm pretty sure that that is a Nintendo designed board on there. Not 100%, but attract mode something. Attract mode HV. I wonder what that is. It says it on the circuit board. Attract mode HV. That's weird. No, that's cool. There's a little line showing you where the video comes out. That via right there.
I wonder if our track just cycles through the games.
It might.
The game intros? I don't know.
No. I was gonna say maybe they were showing you which pins to tell you what mode it's in. I don't know. Any event. Where's that web page at?
It's on the other tab.
Oh, okay. Should have brought the TTL cookbook. That would have been nice right about now. So it's 1, 2, 3, 0 is the magic numbers. 1, 2, 3, 0. So it's 1, 2, 1. Oh, that's right. This has that freaky power pin out. 16, 15, 9, 8. 16, 15, 9, 8. And that is 1, 2, 3, 0. Okay. That's a 75. 2, 3, 6, 7. Those are data inputs to that chip. Or pins 2, 3, 6, 7 are data lines 1, 2, 3, 0. That's a good sign. Where's the pin? So bit 0 is pin 7. We got 11. 11. 10. 9. 9. 11. Let's say 11 was 1. 1 is pin 2. 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's 10. 10 is D1. Yes, that's right. 9 is D3. D2 is... Oh, no, that's D2, I was going to say. Yeah, usually they go in order. Would be the most common, so we're talking 6, 8, 7, 6, 4, 5, 6, 7, 8, yeah. So there's D0, 1, 2, 3, and the 2 latch enabled. So basically, if you want to write the numbers on that display, you load 0 through 9 on these 4 data lines, and you hit this one to show it on the 1s, and that one to show it on the 10s. That's it.
Cool.
So that's how that works. So that's done. Oh, one more thing. Select button. This ground or power, I wonder.
That
Power.
one's green.
That's
Oh,
power.
Oh, I see.
Yeah, sometimes it can be tricky like that. It looks like it, but it's really not. Here, just 19, 18, 17, 16, 15, 14. 14 is the select button. So that's that. That's easy enough. Yeah, I wonder if they made that in ASIC to make it harder to figure out how the lockout circuit works. That's a possibility. Because Nintendo's bastards like that. That's your oscillator. That's your oscillator right here. Crystals across those two pins of that inverter, and then they buffer it here and then here. So that's probably how they're going to be operating this chip. So I mean, one thing you could do if you want to just do a quick mod to stop the resetting is you could kill the clock to this chip and then it won't reset anymore. But the problem is I mean, you can wire a switch on there to the reset. But the problem is you got to have a power-up reset when you turn this thing on, and it's got to be able to control that reset. Otherwise, it's not going to tell which cartridges are in there. You know what I mean?
Yeah.
So that's why you can't just pull it off of here and then wire it to a circuit. That's why that won't work. There's a PAL on there. I didn't see that before. Probably not a big deal. PAL 16L8. Oh, it's just combinatorial. There isn't even any registers in that. So that's basically glorified address decoding, I bet. Still got the 139 though. The other interesting thing, almost all the chips are RCA branded, I noticed. A lot of RAM chips, custom chip, these chips. Very few TI, a few TI parts. Toshiba EEPROM, TI EEPROM. And there's no logic on this. It's just cartridge headers, I guess. Yeah, they buffer all of the address and data lines going to each set of 4. It looks like. So, and then I got this 154 that selects all one of the 12 cartridges here. That's why there's 12 of these little ferrite bead jumpers that they're not using. One of these selects each cartridge, so you'll find one connection from this chip goes to each. There's a separate connection from all 12 carts to that chip. That's the one that selects the actual cartridge. So that's that. And then there's this latch here. So you're saying that this, where's that switch at? Do you have it off?
Metered out, all it does is
It just connects one pole to one of the 4 connections, right?
ground.
Yeah. So it's just a 1 4. Oh, that's a pretty good switch there. That is a 3-pole switch, it looks like. 3-pole 4 position. Looks like it could be up to 8 positions.
Yeah.
But it's restricted to 4, isn't it?
I'm assuming that's a stop pin
This?
right here.
No, that's your detent ball. When you turn
It doesn't move.
It doesn't move, really? Oh, then you're right. Oh yeah, you're right. It is a stop pin. Yeah, you're right. That's exactly what that is.
That's why I cut the slot in, because the shaft had broken off, and I was like, well, I want to see if that thing moves. And
Oh yeah, you're right. It is broken, isn't it? I thought it came that way. Oh really? That's kind of a crappy switch. At least there's a part number on it. That's an ITT switch. You may be able to find that in DigiKey or something.
They have.
Oh, that's right. You said in the video you found that, didn't you?
Yeah.
Yeah, I thought it was designed to adjust with a screwdriver in the video, but no, it's broke. Yeah, I can see it now. You can see the plastic is indeed broke there. Huh. 14 pins on it. Huh, maybe that's like a 12 position switch or something. There's 9 holes in there, so it's at least 10 positions. Made in France. Well, that's why I gave up. So, does it say on the back what those do? Oh, okay. And it mounted with like this. Yeah. Okay. You have a flat blade for that? Two. One. 37. Did you say you figured out where that switch connected?
40, 39, 38, 37, I believe.
Oh.
No, sorry, 21, 2, 3, 4.
Oh, okay. Because I'm not getting any continuity between those and ground.
No, you won't.
Why not?
Because that's what the switch does.
I know, well, it's plugged in.
Oh.
Maybe the switch is broke. Yeah, I got the switch plugged in because pin 1 is marked on here, right? Where it says, yeah, you got a little mark on there because it says 1 right there on the
ground.
switch. Yeah. Is that ground? Maybe they went positive logic on it. Well, it is indeed ground, yeah. Yeah, you're right. 21, 22, 24. Maybe the switch is broke internally or something.
That I can almost guarantee it is because I had trouble getting continuity.
Oh, you did?
Mm-hmm.
Oh, like the contacts are oxidized or something.
I don't know.
I'm just curious what the 4 positions where they connected. Cause see, we got ground on the metal work, so. Oh, there we go. 5.3 ohms. Yeah, those contacts are pretty dirty. So you got 24. I'm sure they go in order. So 24 is 30 seconds. Really?
Got to keep the kids away, right?
Yeah.
That's when there's a long line of kids wanting to play it. That's all you get. 30 seconds. You go back in line.
Yeah.
Unless you're a big kid.
Yeah. 130 ohms. Yeah, that switch is pretty
Yeah,
crap.
if you just play with it, it'll probably change too.
Yeah, I'm sure it will. That's why I like going like that. Yeah. 200 ohms. Yeah, they're all in order. Except this one's open. Oh yeah, I saw it change when I wiggled the switch.
Probably play with the shaft. And
Right, yeah.
Turn off.
Oh. Yeah, it only does it once, and then you hold the blue button. It's better than the flutes we got. We got the 170. Yeah.
Oh, the 170s.
We got the 179. It's a piece of crap.
Yeah.
The thing
I've had this one for a long while, and then I was salivating over this one big time.
I see that. Ooh. Yeah, see, I was thinking about going with something other than a flute, because I've used flutes for forever.
Dave was all about this one. So
oh, was he?
I looked all over.
Yeah, I watched some of his videos on
crazy
that.
about the probes. I hate that they're covered and they're not very sharp.
We'll just
They're nice, so they couldn't.
get a really nice.
Well, these are uncovered and they're a little bit sharper, and that's why I kept it. But this one, the beep on this one is non-existent.
Oh, really? Yep.
Did you hear it?
Barely.
That's it.
That's it?
I even had
that's
a part
horrible.
and it was like all corroded over the buzzer, but
You cleaned it and it
did
still
nothing.
didn't do anything.
There's even a menu item for making it louder, and
And it doesn't seem to do much. Yeah, I wanted to actually get my hands on one of these and play with it a bit. Here, maybe I'll use yours instead of mine for this continuity.
It's super loud.
I've had this for 20 years now.
Yeah.
And I shopped it out recently, so it's all nice and clean. But I have the problem with the LCD fading on it. So there's like a kit you can use to fix that. So let's see. We'll do the Dave test here. Oh, that's I don't know. Oh.
You're not even in the right mode, are you?
Oh, I thought I turned the beeper on.
Did you?
It's this button, right?
Yeah.
Okay, yeah, that's pretty
What's funny
decent.
is that
I like how
release the
I like
LCD
that.
faster than it beeps.
Yeah, I noticed that. I like that actually. That's pretty cool. Yeah, I like that. Yeah, actually, I like that. So we'll give that a shot. See, I do this quite a bit. I do actual tracing out like this. So we'll see how that works. So 30 minutes, 6 minutes. That's funny. So it goes from 30 seconds to 3 minutes to 6 minutes to 128 minutes. Yeah, that makes perfect sense.
Huh.
Why is there not like, I don't know, 15 minutes? Half hour? Why does it go from 6 minutes to 128?
You got me.
I don't know. Blame Nintendo, I guess.
Why not unlimited instead of 128? That's what I want
Yeah,
to know.
that's a good question. Oh, you know what? I wonder if you do not plug this in.
Still 128.
It's still
I
you try.
tested
Did you try multiple grounding combinations? That might be something to try.
Yeah, I didn't.
Granted, there's 16 combinations and only 4 of them are known. So who knows what the other ones do? I would
I'm
probably.
assuming just get some weird times in between those. But
Well, if there's a micro in there, it'll either do nothing or default to 128. So
well, the other guy that was trying to work it out, he's over in the UK. I think he was trying to
Oh,
get the
did he
combos,
do
and he
that?
would always get 128.
Okay, so that must just be the default then. Well, that's kind of crappy. Okay, so we got that. So we know where the select button. We know how to run the display. So my question is where does the selection on that 154 connect? I'll have to look at the list. 54. Selection is 23, 22, 21, and 20. What I'm wondering is if they didn't just parallel those LEDs with this. You know what I mean? If they just hooked these straight up to that, because this has 4 inputs. No, they almost couldn't have. Okay. So it's these here. So that is 0.
You're already hitting that shroud, aren't you?
Yeah. Actually, I might do this.
Here, put these on.
Oh, you got other ones? Oh, yeah, those ones. I bought a set of those at work. Those are fluke probes, aren't they?
No.
They aren't?
No.
Oh, that looks identical to the set of fluke probes that I had. Yeah. Oh no, they are slightly different. I have a set of fluke ones I bought off of DigiKey like this. I bought 2 sets for work, and they died within like a year.
Really?
Both sets did, yeah. One died after a year, and the other died after another year. So I was kind of disappointed. I bought this set of these probes on this one just recently because the ones I had on here were 20 years old. And they were still going, but the rubber started deteriorating, so the probes didn't actually break after 20 years. So I thought that was pretty good. So yeah, I like that. Yeah, that's pretty awesome. So oh yeah, we're checking this. So we think that this connects to this latch probably, and it does. I wonder why they latch all their. I wonder why they latched everything. 0, 1, 2, 3. Okay, so this is 0 right here. That's 1, 2, 3. Oh, that's interesting. I wonder why they did that. It says 154 on there. Wonder why they have this on there. These ferrite bead things, these FBs, they're shorted out. Yeah, this is normally ground and the signal passes through it, but the outer two are shorted like there and there and there. They're for like this type of thing. I don't know why they have them on certain pins of that chip. And why only certain things are latched and others aren't. You'd think it would connect there. Where's the enables on that thing? I think they were all in a row. Oh, they are in a row. The enables are right here. So one of these is probably going to connect to this 139 if I had to guess. No? Well, that's a mystery. Guess I can unplug that. We don't need that anymore. Yeah, that's good, thank you. Oh, that's so much better. It can actually work now. Oh, I wonder if that's what... that's very strange. These two gates of it aren't being used. That's a 370, that's a latch right there. Clock is right here. So that's going to connect to the chip somewhere, I'm guessing. 5. What is that? U23. And I wonder if the data lines 8, 9, 10, and 11 go to that chip. 4, 5, 6, 7, 8. They do. So this is in parallel with those latches on that little circuit board. For whatever reason, they decide. I mean, they got 40 pins here. Why do you have to latch all that stuff? If you got all those pins, why can't you do it in the chip? Hell, you made an ASIC for it. There must be some reason for it. And it's also interesting to me that it's 4 bits instead of 8 bits. Kind of lending to the theory that there is a 4-bit CPU in there. Maybe. Well, those aren't on power. Is it? How close is it to 128 minutes? Is it pretty close?
Almost exactly.
Okay, so that means it's working off one of these crystals. Then, if it's exactly 128, so it's either working off of this one or this one. This one's driving the lockout chip. Is because if you look at an NES board, this is in an NES. Have you ever seen it? That little blue thing, the little blue square thing? That's actually a resonator. It's a crystal.
Oh, really?
Mm-hmm. And it says 4.0 on it, I believe. I think, if you have a front loader board kicking around.
You got a ton of them.
Somewhere.
Right here.
Yeah, right there. That says right on the side right there. 4 megahertz. So that in this chip is this and this. That's
Okay.
the same chip. Actually, here, let me see that.
That's the SICK.
What?
There's one right next to it.
Yes, mm-hmm. Oh, this is the 04.
Yeah.
Actually, that's pretty good because... Oh, so that's what that board looks like. I never actually saw one close up.
Almost nothing on the bottom.
No, just probably bypass caps, if anything. Oh, no? Oh, it's top
There's
load.
only like 3 or 4 traces on it too.
Oh, okay, yeah. So it's top load out only. That probably made it a lot cheaper. Oh, okay. Yeah, yeah. That's a pretty nice board layout. Is it 4 layers?
No.
Sure, I think it is.
Would you be able to see it on the sides?
No. Here, look at this one. Can you see it?
Is it the? I think it was the Game Gear.
Oh, you
PCB,
can actually see it because probably because the plane goes all the way out to the edge and then they routed it off and you could see it. Yeah. I don't know. It's hard to tell. Usually the telltale sign is vias that don't go anywhere.
Right.
I don't know. Maybe it is. Maybe it is. I guess it is only 2 layers. Usually the giveaway is the power, but yeah, it does look 2 layers. Oh yeah, there's their little level translator chips right there.
Mm-hmm.
There's the flash RAM for configuring your FPGA. There's a little SRAM. And then your converter,
Video encoder.
yeah, 7236. That's a very classic part. Oh, and you used resistors for the DACs.
Mm-hmm.
R2R by the looks of it. Man, why doesn't anybody use a video DAC? I guess it costs too much. Oh, those are 8 bits too. That's funny. Huh. I wonder what that SRAM does. I've been wondering that since I saw pictures of this board.
Fuck shit up. It's the wrong one apparently. You hear about that debacle?
Yeah, there was a timing issue, wasn't there?
Mm-hmm.
Yeah, what was
It took 7 revisions to get it right.
7 revisions?
The firmware, yeah.
Were you uploading the new firmware to that flash ROM, or did you send it back?
No, I don't
Oh, you did. So you have a.
He actually sent a few USB adapters
Oh, did he?
to various people.
Okay.
He's trying to do a friend kind of a thing, you know, if it's just one person, he'll
Then send it back, and if you
send
have.
it on to the next guy.
Oh, I see. Oh, like a chain.
But apparently he has a guy doing the US distribution.
Okay.
Yerky on Atari Age.
Okay. Yeah, I think I know him.
He's famous for something, I can't remember, maybe in television or something, but he handles all the US stuff now.
That's a pretty nice little board design there. I like that board design. A lot of times you see some board designs and they're just like horrible. Like they're all auto-routed messes, but this one's all real nice.
I can't remember if I had any left or what I ever left auto-routed. I don't think I did. I finally figured out that you needed to do it by hand, especially in Eagle, because those auto-routes are...
I know, I've
so
never
bad.
found an auto-router that actually works.
Apparently there's one that'll online that is really
Oh
good.
yeah, Joe uses that. Yeah, I've been... I mean, it's okay. I personally, I like hand routing it because it's kind of fun. It really doesn't take that long once you get good at it.
Oh, it's super fun. I love it.
Like on a board like this, the nice thing with this FPGA is you define the pins, so
you can change the traces
yeah,
to whatever
exactly.
you need.
You know, on my board, that's how that works. If you look at the board, all the routes are all straight. There's no crossovers, and that's why.
You want to take the new Universal PPU with you?
What, do you have one?
Well, no, not an actual board, but he dumped everything public.
Oh, I have that. I
Oh,
downloaded that. Yeah, I looked at
Take
it.
a look at it.
I did look at it. Yeah.
The biggest thing is it just doesn't fit. But I started going through his bill of materials, and on his bypass caps on the bottom, they're the
tantalum.
0206, not they're the 0602. No.
0603.
They're the wide ones with the metal on the sides,
yeah. The reduced ESL caps. Yes.
Okay.
You don't need those.
That's what I said. I was like,
Well, you don't even need that microcontroller on there. What's that microcontroller doing?
I don't know, something with pallets maybe.
Well, you can do that in the FPGA.
I don't know. I have to ask him.
Well, see, on my work, we have this product. It's a controller, and it uses a Z80, EEPROM, just like this, a 27256. It uses a 128K RAM chip. Oh, that's 74139. All this old stuff, you can't get this stuff very easily anymore. So I was like, okay, well, we had to make another run of boards, and I'm like, well, what are we going to do? We can't buy half of these parts anymore. So I made an FPGA that, powered off. I made an FPGA that replaces all of that. The Z80, the EEPROM, the 139, all that TTL stuff is all in one chip now. So the Z80 is actually in the FPGA, and there's a 6502 in there that actually is like a supervisor. I call it the hypervisor. So it handles things like loading the code, starting the Z80 up, and all this other housekeeping crap. So that's why I'm saying you didn't need the microcontroller, because you can just put a core in the chip, the FPGA you already have, and do it all in there. So that saves you money on your BOM. So yeah, I looked at the BOM after you told me about it, and yeah, there's a lot of things you could cut out of there. I didn't catch those caps though, but those are kind of expensive.
Well, my main concern was I'm not going to be able to hand solder that stuff.
Oh yeah. Well, you can. Yeah, it's not that hard.
I've never done one, I should say.
Yeah, you can do it with that iron. I bet.
I'm not using that. This is what I use right here.
Oh, that's even nicer. Yeah. Oh yeah.
This is shit right here.
Oh yeah, that's pretty. Oh, is that RF? Is that RF? Sure.
I don't know. Started going techie on me.
I think it is. Is that like a coax cable? No, maybe it isn't.
It just senses that it's in there and shuts it off.
Oh, that's cool. Yeah, who makes those things? It's that really expensive soldering iron. It's gonna bug me now. Metcal. The Metcals, it's actually a radio transmitter in that base, and it heats up the iron with RF energy, kind of like a microwave.
Oh.
It's really cool. I kind of wanted to buy one, but I've used one and it does work pretty well, but just for the money, I just couldn't justify it.
I love that.
Yeah, I use a Heiko at work and at home.
Yeah.
So, I mean, it's probably pretty similar to that, and it's awesome.
The only reason that I wanted it is because it goes into sleep mode, so it shuts it down to whatever you set it at, like 200-300 degrees, and then when you pull it out,
Fahrenheit
it's
or
automatic.
Celsius? Fahrenheit.
You pull it out, and it automatically heats it right back up, just real quick. That's another thing about this one, is it automatically. Nope, it's the Radio Shack.
Oh, Radio Shack.
I've got an old Radio Shack. It goes,
So the
it goes
radio-
right to the continuity.
That's what I liked about. That's what this one does too. But the thing I don't like about this one, it doesn't turn the beeper on when you go to it.
Really?
Yeah, you have to hit that button to make it do that, which is kind of a pain.
And this one, you can't just slam it over to off.
Yeah.
It'll go one more.
Oh, it'll go one more. Yeah, you know what's funny about this one? If you hold down one of these buttons, this turns on the ultrasonic data output mode that
sweet.
nobody ever used, and it never got docked. Someone actually finally documented it. I think it's min-max, is it? No, let's see. It actually says on there. Ultrasonic data output, hold button. Hold. You can actually, I think
I can hear something.
it makes like a buzzing sound. Oh, there we go.
I can hear it.
Not funny.
Sounds like a dead alarm clock.
Yeah, it's like So, yeah, someone figured out the data format, and it's really simple. It's actually the segments on the LCD. It just outputs them just as a string. That's it.
Huh.
It's really simple. But Fluke never made a thing to use it. So it's like, well, why did they add it if they,
Interesting.
I guess I thought it was a cool thing that they were going to do and they just never did because, you know, does yours have this? No, oh yeah.
That's in there.
Right there? Yeah. Yeah, because Dave on his page was showing that. No, I need that actually. I was gonna, you have one without the board on it?
Yeah.
Oh, that's much better. So I was gonna poke the lockout chip real fast, see where they connected it. Yeah, I thought it was really funny their progression. This is a Rev 10 board of them adding more and more parts to prevent lockout defeating circuits from working.
Right.
So they added this diode, and then on the Rev 11 they added resistors also. So none of those lockout defeating circuits work on the 11.
Really?
Mm-hmm. If they use the negative voltage to stun the chip, they won't work on an 11. That's how that works. It pulls a negative voltage on the pin and it crashes the CPU in
Like
there.
on the tangents and stuff, you mean?
Yeah, no, that one actually has a clone lockout chip. They got in trouble for that.
Oh, so the Pirates, like...
Yeah, like Color Dreams.
Caution and stuff like that.
Yeah, Wisdom Tree. They all have a circuit that applies a negative voltage to one of the pins and it zaps the lockout chip and crashes it so it can't reset the system anymore. That's how they do that.
Right.
Oh, the solder's gone, or the tin plating's gone.
Sandpaper.
Mm.
Wasn't me, but I've done it before. I think that's what it looks like.
And did you put that on there?
Yes, I did that. And it probably didn't work. That's why the whole board is void of some chips.
Oh, okay. And pin 4 is cut on the lockout chip. It's kind of crummy that that one cartridge needs a lockout chip to function for it to reset properly. That Nintendo World Championships. Without a working lockout chip, the game won't work.
Ah.
That's like the only one. Okay, so what I was thinking about doing is trying to figure out. I have a theory. Let's see what you got here. You got an 08 and 08, a 540, 130. Oh, there's two 139s. Why is there two of them? There's that PAL too. So what I was trying to figure out is how this lockout chip was hooked up. If it's using this or if it's using this. Because I got to multiplex all of those lockout chips down to this one somehow, and I was trying to figure out how that worked. Oh, you have a 251 right here, and there's a 251 there, and another one here. And another one there. 1, 2, 3, 4 of those. Those are multiplexers. 8 input, 1 output. So... the 151. Oh, that's yeah. 5 and 6. 5 is true, 6 is complement. Okay. So this is data coming out. Okay, that's how they're doing it. This chip and this chip are multiplexing all the lockout chips to that. They all go into those two chips and it ends up there.
What other lockout chips?
On the cartridges.
Oh, see, I see what you're saying.
Yeah, if there's no lockout chip on a cartridge, this will skip it. That's how it knows where the cartridges are. That's why I was surprised that the flash card didn't work. So what it's doing when it's scanning through the games, it's actually selecting each game to see if the lockout chip is responding. If the lockout chip doesn't respond, it thinks there's no cartridge in there. It's going to say there's none in there.
Interesting.
That's how it knows. So that's what, when you turn it on, when it I saw it count through those numbers. That's what it's doing. It's actually querying all of the lockout chips on all the cartridges. And if there's no lockout chip registered, it's like, oh well, if there isn't a lockout chip in there, I'm not gonna,
Play it.
Yeah, yeah, exactly. So that's how they're doing it. So the select lines of those are 9, 10, and 11. So those will be connected together. Here, these will be connected, these will be connected, and this will be connected. Because 9 is going to be operated somehow off of this chip. Yep. Yep, and then, so D, 0, 1, and 2 off of this latch is selecting which cartridge's lockout chip is going to be visible to this chip, to the lockout chip. So they all go into those 2 chips, and then it goes into the lockout chip. So D0 is 11, 2019, 18, 17, 18, 15, 16, 12, 11. 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's 11. So 11 is D0, so they'll probably go up here, and this will be 10, 9, 8. Yep. So that latch is hooked up how we figured it is, and this goes to the 251 lockout. I'm guessing bit 3 is going to select which lockout chip is being used, and they're probably going to use this inverter to select them. I had to guess. Output enable is 7. So pin 7 on one of these chips is going to connect here, I suspect. And it won't connect here. So this is going to connect to an inverter somewhere. So they got an inverter somewhere. 139, maybe they're I doubt they're using a 139 for it. There's no 4 up here though. There it is. So this will connect to the other pin 7. And that's the input, and that'll connect here, I suspect. And it does. So this is a 251 select. So that is how they're selecting which lockout chip is visible to this chip. And then I'm guessing that was what, pin 2 was it? That was pins. So pin 1 is the data out, and that will be buffered and connect to every single cartridge. So they're probably passing it through these these buffers somewhere. Let's see if they're buffering it through here. Nope. Nope. I doubt they're using that PAL. So it looks like they just direct connecting it. Yeah, the Famicom box is pretty interesting because it's very similar to this, but it has 15 cartridges. Have you ever seen a picture of it?
Oh yeah.
Yeah, it's got 16 cartridges. The 16th one is inside on the circuit board. There's a cartridge connector. One of these, in fact.
Now I heard that the carts in there don't work in anything else.
They work fine in an NES. The lockout chip has to be disabled for them to work.
Well, I thought it was a physical thing.
Nope, they fit. They're just a black NES cartridge shell.
See, that's what I thought they looked like, but there was somebody that had said somewhere that
they're wrong.
That was a different size. Okay.
I've done it.
Okay.
I've dumped them on CopyNest. So what they do, You know how there's these 10 pins that aren't used?
Mm-hmm.
They use 4 of them, and those run to the lockout chip. So the lockout chips in that system are all networked. They're all connected in parallel. And that code is, those 4 bits is different for each slot. And that tells the lockout chip which chip it is. So the cartridges, you know, there's 4 lines, so that's 16 different possibilities. So each cartridge is wired up with a different code. And the internal one is 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way to 15.
So then you can't put a regular NES cartridge in it.
Correct.
I see.
I hacked
Maybe that's what I read.
I hacked the BIOS so you can do that. Because what it will do is, it's just like this. It will not play a cartridge it can't find.
Mm-hmm.
And so I hacked the BIOS to allow you to play cartridges it can't find. It lets you select any port.
Mm-hmm.
So the other interesting thing on that system, there's a watchdog timer that actually checks if the game is reading the controllers, and if the game doesn't read the controllers, it will reset.
Huh.
That's how it can tell it's crashed. Because this one, I noticed when it crashes, that's it, and it doesn't reset the game, does it? It just crashes, and then you have to hit select or wait for it to time out, I guess.
And I also grounded out the reset, was it pin 3 on CPU?
Yeah, and it did reset.
And
yeah, I did
reset
see that.
That was excellent.
Yes, that's perfectly valid. I'd probably put a resistor in series, but yeah, that's perfectly valid. What I would do, you could probably make a circuit with a switch that connects to the circuit. So what you can do is that would prevent this from resetting it. But you know what I mean?
Mm-hmm.
So you could have like your own reset button, so you can switch the switch so it works like it normally does, or you can have it so you have your own reset button you can press. You
definitely needs that.
That'd be really easy to do.
Especially for the power pack.
Yeah, oh yeah. Yeah, I mean that would be like, you have a switch. So this would be reset CPU, reset, and then this goes off to the ASIC like usual, and then you have a resistor, a diode, and a cap, and then a button like that. So what this resistor, diode, and cap do is that is a reset circuit. You probably don't really need that, but you can get rid of the diode and the cap, but you still need that pull up, of course. So that's all you'd have to do. So you switch your switch. In this position, it'll work like it always does. Switch it in this position, then you can hit that button to reset it at will.
Sounds simple enough.
Yeah, that would be the easy solution. And you could mount it on a little plate here, like you said.
Might be running out of room on that plate already.
Oh yeah.
There's gonna be a multi out there.
Okay.
Maybe a pallet switch, depending on whoever buys it, if they want one.
Mm-hmm.
Maybe stereo audio switch, if they want that.
I think that's hilarious that they made this little riser specifically for that useless expansion port. It's like, why?
Oh, somebody cried about that already.
Oh, really?
Oh, you need to leave that in there. There's going to be this new thing for...
Yeah, I know about that new thing, if it's what I think it is.
Not the Inyo.
No, it's
That's the old thing.
Yeah, I can't remember what it's called. Doesn't it have Ethernet on it and stuff, that thing?
Maybe. I can't remember. I don't know. That thing actually said what it was. But
Yeah, that was, you know... Guy at work has a proto of that. I was looking at it. It looked kind of neat, but he's never made it, so he never really released it, so... What can you do, huh? Will this power off if you're using it? That's one thing I didn't like about the Fluke. If I'm, actively probing, and it'll just die, and I think that nothing is connected, and I have to keep looking at it to make sure it didn't die. And it's, it's really an open circuit.
At least this one beeps when it
Yeah, how do you like that? So,
and I'm sure there's a way to set.
I'm sure there is. You probably
quickly
hold the blue or the orange button when you turn it on, and it'll disable that. That's how mine works. It seems like all multimeters have to have a blue button on them. True.
Yep, this one's got one.
Yep.
Does the Radio Shack?
No, it's Radio Shack. It probably doesn't.
Barely even has any buttons. Nope. It's got a yellow.
I see that. Oh, I know someone that has one of these. Yeah, and if you read the back, it says not for professional use on it.
Right.
It does, doesn't it?
I don't know.
Let's see. Oh, and my friend does it. Says that, and I'm like, well, why does it say that? This one actually doesn't say it. Yeah, the one my friend has, it's older than this one. It says not for professional use on the back of it. I'm like, well, what's the point of that? This one's actually UL listed too. His isn't. So this must be a newer one.
I'd say it's still 5 years old.
Oh, his is
maybe
like
4.
20.
Mm-hmm.
So, I'm sure it's perfectly serviceable.
I don't even remember why Work bought me that one. It had something to do with, red frequency.
Oh.
And the one I had did not.
Yeah, that's always a handy thing.
Yeah.
One thing that I like that Fluke's about perfect. It has one fault. It will not test capacitors over 4 UF.
That's it?
That's it. But I have like a 79 at work that's older than that and crappier. It'll go up to 10,000 UF. So it's like, why is it not? I still can't figure that one out.
I don't remember what the limit
I'm
is
sure
on
these
the
ones
time
probably are
is.
at least 10,000.
Might be.
It's not very often you test something that big, but I mean, I test caps for like 100 and 200 UF, and so 4 UF is like pretty crappy. So that's the one flaw in that
I
Fluke.
bought a completely separate LCR meter for
Oh,
that,
you did?
so I can do ESR.
Oh yeah, I don't have one of those yet.
I've got another one if you
I made an ESR
I
meter
think I've got
though.
3 actually.
Oh, really? Yeah, I made an ESR meter.
This is what I'm using.
Okay.
Cheapy eBay Chinese.
Oh
piece of
yeah,
crap.
oh yeah. Tong Hoi.
And I've got a whole nother one right here.
Oh cool.
They, of course, I paid for it and it didn't show up, so I bitched.
And they said
sent me
another one?
and then right after that, the other one shows up. And I'm like, sweet.
That's pretty cool. I like their big fat connector. You have to have that though, because of the resistance.
Oh really?
Mhm.
I wonder why it was so big.
Yeah, because you're measuring things that are, under an ohm, so your test leads and all that have to be really low resistance.
I've got another Agilent
Oh yeah.
that I've never used.
Cool.
This was the first LCR meter I bought. I don't think I ever used it. I don't remember what the deal was with this one.
Is that an eBay special?
Definitely. 5 years ago, eBay special. So who knows if it even gets made anymore.
Yeah, there's a really interesting video on.
Oh, I know what it was. This one doesn't do ESR.
Oh, it doesn't do
I
ESR.
don't think it does.
Just inductance, resistance, capacitance, and no
That's it.
ESR.
That one's a dual readout.
Oh, this one is?
Mhm.
Oh, yeah, I do remember that. I did turn it on. Yeah. Well, proper ESR meter it does have the 2 readings on it. Because, you got dissipation, ESR, resistance, and capacitance, and inductance, so.
Can be yours.
Cool. I'm definitely interested. Cool. But yeah, let's see, we'll finish up real fast here. Here's this. Yeah, I've seen you use that one. That's right. I was trying to figure out where pin 1 went, because pin 2 is going to this multiplexer. I think it's. Yeah, so pin 1's got to connect to all of those cartridges somehow. So I was trying to figure out how they did that. So basically all these chips here are just buffering. These chips aren't really doing very much. So I know what these other 251s are doing. They're multiplexing the mirroring bit. Where you put those jumpers on the board, this is selecting those mirroring bits. So if you want to make interrupts work, you would get more chips and just piggyback them on here and connect the wire from each interrupt line on the cartridge to these chips and connect it to the IRQ on the CPU, and it should work.
Oh my.
And that'll make MMC3 games work.
And 1 apparently also?
Well, 1 should work. I'm surprised it doesn't. There must be something weird going on. It doesn't start at all?
It goes straight to blue screen.
So it doesn't start then, yeah.
I think it doesn't even work on the EverDrive.
Okay.
Abidox itself, not just MMC1 stuff.
Maybe
And then on the Power Pack, I have the Fox's save state mappers.
Uh-huh.
So that might be doing something too. I don't know.
Well, the game I kind of remember something weird about that game when I was trying to get it running on my FPGA. There was something strange about that game. I can't remember what it was now.
And it's just a fluke that I use it because it's an A-letter game and it's like a popular list on the Power Pack.
Oh, that's it.
No other reason why I use it.
Oh, that's a good reason. That's interesting. Someone hand wrote those on there. So that's a 16K ROM, so that's a pretty small ROM. I think I've actually run that on an emulator before, that ROM. So, Anyways, I'm curious what this is doing. This 154, I'm pretty sure I know what that's doing. Hey, do you have a big cartridge board, something big?
A big what?
Cartridge board. Oh, actually, you have an NROM board. I need an NROM board. That'll be perfect. Yeah, I need the circuit board.
Does it have to have chips on it?
No. It would be nice, but it doesn't have to. I just have to. I just have to be able to poke chip enable.
Yeah, I'm good.
Awesome. Yeah, this is like the Famicom box has these exact same connectors on it. It's gonna be a bit tricky, but I think I can get the meter in there. So, chip enable's right there. Okay.
Move it down.
Oh yeah. Just gotta be able to get to that chip enable pin. Chip enable lives. No, I gotta be one up more. I can't get the probe in there. Chip enable lives on that one pin on the back of the chip. So pin 1 has to be over here. So it's 3, 4, 5, 6. Chip enable is the 6th one in. Chip enable is grounded, so output enable it is. Okay, that's very interesting. I was sure that that would have connected to this, and it doesn't. So that means, do they using the PAL for that? Nope. There's no 138 or anything on here. There's 139s. No Wave a Dead Chicken here. Yeah, I didn't think so. Oh, there's a one. Oh, here it is. There's a 139 here. So there's the first cartridge. Okay. That's the first cartridge. Why did they use 139s for this? That's strange. Chip enable is here. Huh, I wonder. Oh, I know why they used 139s, I bet. So it's going to be here. Then here. And then here. Okay. So this 139 selects these 4 games, that half of it, and this half is going to select these ones, probably. I had to guess. Unless this one's doing it. So that half of the chip may not be used. That's why they did that. No. No. So they use this half of that 139 to do that. Is there another 139 on here? There's one here, one here, one here. I didn't try this one. This way. So it's 3, 4, 5, 6, 7, 8. There it is. It's possible I just wasn't really. Oh, that's very interesting. That is very, very interesting. That's not very good. Okay. I think I'm kind of seeing a problem. Games that have save game RAM probably are not going to work in this.
Yikes.
We should try 2 cartridges or more that has save game RAM and see if it works eventually.
Zelda Outlands?
What? That does. What game's that?
Zelda Outlands.
Oh, okay.
Zelda.
Well, if you got multiple copies of that, just stuff them all in there.
Yep, like 5 of them sitting here.
Yeah, what they did... Oh, so that's how you solve that little problem. I was wondering how the best way to do that.
Yeah, it was a problem. That was the 5th battery holder that I
That
bought.
you tried?
Yeah. Couldn't get them thin enough.
Mm-hmm. Yeah, that was the problem I had. I use this at work. I use that. I use a surface mount. In fact, this right here is the surface mount version of that.
I couldn't get the surface mount version to work.
Oh, really?
Mm-hmm.
Well, yeah, you need the
covered
pin.
up everything.
Yeah, you need the pin. I through-hole one smaller. I use surface mount because when they stuff the board, it's cheaper. It takes more room, though.
Right.
Mm-hmm. And this perfect. So what they are doing, it looks, is they are enabling all 3 of these cartridges at once.
So like as sets
So
of 4 maybe?
it's sets of 3. So this whole row, this whole row, this row, and this row.
Mm-hmm.
And then they're using these other chips to enable which cartridge actually runs to the bus. So they're doing like a multiplexing kind of arrangement. Huh, that's very interesting. I wouldn't have guessed they would have done it that way. Well, that explains quite a few things then. So that explains why this is not fully populated, why all these lines aren't being used. Very interesting. So the selection inputs, here's the enabled. So this enable's probably going to connect to that PAL or one of these 139s. Oh, yeah, that's the cartridge enable right there. So that's the cartridge enable. So this is cartridge enable outputs connecting to this, which is turning all of these on in groups of 3. So this one here should connect, or is it this one? I can't remember. Or is it this one? Let's see, enable. I'm trying to remember how they done it, how they operated that. A15 should be right. Crummy thing is they got these friggin' 541s on here. That's a pain in the ass because it makes it a lot harder to trace, because I know where the address lines on this are, and then they connect to this, and then they connect to everything else, because this chip doesn't have enough drive to drive all of these chips. That's why there's all of these buffers, is because there's just not enough oomph to drive all these cartridges, because these lines, these wires are very long.
Mm-hmm.
You know, you got to connect from here down to the board, onto there, and then you got to connect from here through all these routes to here, and then into the CPU. So that's why there's all these extra chips that you normally wouldn't need. Yeah, the Famicom box is just like this. It has three sets just like this. Only they didn't use an ASIC; they just used all TTL, so it was a lot easier to figure out. So then we got to figure out what's controlling these. I have a very good idea what's controlling those. See, I know the pin out of the 139. It's enable AB0123. Enable AB0123. So the enable, we know where it goes. So these 2 select lines are probably going to run to this. Well, I guess when you're using it,
it doesn't matter.
I'm going to hold the yellow button down when it turns on. No, I didn't do it. Okay, so we'll check over.
Probably in the menu somewhere.
Yeah. Okay, so these are in parallel, so... Oh, I bet that other one, this other side, is the PPU enable, I bet. We'll follow up on that in a minute here. It's interesting. So that goes there and there. Okay. So 0, 1 equals C select 0, 4, 8, 1, 5, 9, etc. Via 139. So it's kind of, so all the magic is happening pretty much here. So basically what they're doing, there's 4 of them, so the cartridges are arranged 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is what you would expect them to be arranged as. Okay. So that's that. So the other thing I've got to figure out is where that bastard pin 1 goes, because pin 2 is going to these muxers, isn't it? Pin 1 is going to be coming off of something. Pin 1's got to be going through a buffer. There it is, right there, right there. Saw it. Right there. Pin 8. So this is a 541. I can't remember the pin out for the 541. I think it's a straight through pin out. A7. So that data comes out pin 12 right here. And that is probably going to run to all the lockout chips, if I had to guess. Hey, look at that. And guess what? It sure does. See?
Yeah.
So that's just buffered, so who cares? So then that's easy enough. So CIC reset. That is pin 3, I believe it is. So I'm guessing pin 3 is connected to this cap. It's probably going to connect to the our ASIC or that latch. That's interesting. Oh, that was the capacitor charging. If I connect it to ground, it'll do it again. Yeah, I saw a flash there. Okay. Maybe 3 isn't reset. I thought it was. Oh, it's this cap is the reset. Can't remember what pin that connects to. Eight? Yeah, because the system reset comes off of here. Okay, that's pin, what did I say, 8 or 7? 7. 7 is the lockout chip's reset. So if you pull 7 high, it will reset the lockout chip and it will search for the lockout again. Like if it was flashing, it'll actually search again. And it looks like there's a little baby capacitor on it. So try connecting somewhere here. Right there. See, that's out, in, out, in, out. Pin 7. D4. Latch. So D4 is reset. Lockout. Like that. So, and pin 3 is CPU reset. So we got to see where that goes. Oh, guess what? That's going to connect to pin 6. Okay. And pin 6 is reset CPU. So that's getting a good idea now of how it works. So basically what this chip is doing is it's operating the lockout chip, and it resets the lockout chip, selects cartridge, resets the lockout chip, waits a little bit, and if the lockout chip is going to start flashing, you know, like the LED flashes on the top load or front loader, then it knows there's no cartridge in there, and it just goes to the next one and scans through them all that way. That's it. That's all it's doing. So basically, this is pretty much all I need. You'd need to know. I'd need to know to make this do what you want it to do.
Sweet.
So I mean, it's really not that hard. It's just figuring out how it does it. You know what I mean?
Yeah.
So now I'm going to verify. Because see, now that's everything. So with these 4 lines, we can operate the LED displays, this latch, which selects the cartridge, and we can read that switch on the back, and we can read the button, and that's pretty much it. And then clock U23. Oh yeah, this is latch. So, and of course, this is ground, 5 volts. I think there's a few other pins that were grounded. Oh, that's reset. That's reset, I believe. ASIC reset. Or it's 5 volts. 37 is 5 volts for whatever reason. It's very possible that there's test modes on this too. So this, that's your select button, isn't it? 14. Yeah, that's a pull up for the select button right there. Wondering what that was. Oh, here's your reset pull-up. So this is 5 volts right here, or ground, 5 volts. This is reset to the ASIC. Pin 1, ASIC reset. So you got 3, 4, 12, 13, 15, 16, 17. Honestly, I don't think those really hook up to anything. You had this board out, right?
Yeah.
No pictures of the bottom, though, unfortunately.
No.
Darn.
I can tell you all the traces go this way. They can come out real easy.
Oh, can we take it out real fast?
Yeah.
Because that'll just clear all doubt, so to speak. Because I'm still not sure what's clocking it. How's it? Oh, I see. Oh, that's right. Those come out, and then the whole front part comes off. I wonder what happens if you would call that 1-800 number.
It's probably the same one. It's always on everything, and it's been.
Oh, they think
defunct.
it's still a live Nintendo service number?
No. It's been defunct for quite a while.
At least it's not like that.
I had heard stories that somebody had got a hold of it and like did something funny with it. And I can't remember what the story was now, but
Oh, it comes out like that. Okay.
well,
that's
it might. I haven't tried it yet, but
yeah, I think it'll come out of there. Oh yeah, how about that? Thanks. Looks like the bottom of a Commodore 64. Another one of those washers. Yeah, bottom of Commodore 64 looks very similar to that. That's that tin plating on there. It wasn't hot air level. They didn't do that for, you know, it's relatively recent, I guess. They didn't do the solder mask over bare copper. That's why you see that. That process has been defunct for a very long time, actually.
In this country, anyway.
Well, no, with this type of thing. That's been,
Yeah.
you won't see that for, you know, I don't know what's the date on this. 87, yeah, 8710, 8724, yeah, mid 87. '87 19, 87 19, 87 21, 87 22. Yeah, mid 87. That's probably about right. 87 31. Yeah, getting near the end of 87. Yeah, because you know how to read those, right?
Yeah.
Mm-hmm. Sometimes they only have 3 digits instead of the 4. They leave off the decade for whatever reason, which is kind of crummy. Yeah, this is much easier now. You can actually get a hold of it. So yeah, you can actually see now that. See, I'm interested in 3, 4, nothing. 3, 4, 5, 6, 7, 8, 9, 10. Oh no, I'm counting backwards, aren't I? Oh yeah. 3 and 4 don't appear to be used on the bottom. 5, 6, 7, 8, 9, 10, 11 are used. 12 and 13 are indeed used. 12 and 13.
Wait a minute.
Yeah, see, that's 20.
Is it?
Didn't you say they went to 21 and 22?
Okay. Yeah, I was.
Oh, you saw
seeing
those
these.
vias. Yeah, I kind of got confused by that too. Yeah, because there's all this junk in the middle because they come down. Yeah, and they're via'd over here. Yeah, there, and there. Yep, there. Mm-hmm.
Is this? Do you consider this old design idea to have all traces going this way?
Oh no, that's pretty common because when you do that, then it makes it so you have fewer crossovers.
Crosstalk between the.
No, crossovers where you have to like jumper it. Like I don't know, it's kind of hard to describe. But if you have everything going this way and everything going this way, then it makes routing the board a lot easier actually, because then you can connect anything to anything with the minimum distance and all of that good stuff. Because like when you connect this is probably the data bus here. See, it goes this way, then they via it out, and then they go down this way.
Yeah.
Because that makes routing the board a lot easier that way. This probably was not auto routed, but that's how an auto router would route this. It would go, X would be, in this case, top, and Y would be bottom. Yeah, otherwise, if you, let's say you have routes going this way on the top, and the routes go this way on the bottom, and you have to have a route go this way, you can't, because it's blocked. You know, because the routes are going this way and this way, right?
Mm-hmm.
So that's the reason that they do route them that way. So I'm trying to figure out where these 12 and 13 go. They this board doesn't do it. 20, 19, 18, 17, 16, 15, 14, 12, 13 and 12. Where's 14 go? 14 is the select button. So 12 and 13 go to that connector. They go to that connector to that front panel. So they probably don't go anywhere. They go to the front panel. They probably don't do anything though. They're probably expansion. If they're like, oh well, if we needed another button, So it's possible one of those two inputs might do something like maybe control the reset. You may be able to reset through them that way. Sometimes it's hard to tell. So 15, 16, and 17. So if this is 20, 19, 18, 17, 16, 15, 16, and 17, they don't go anywhere on the bottom. Just for fun. Yep. I'm going to say those are NC. Did you ever have this out?
No.
I like it when there's no sockets. Makes tracing the chips easier because you can just look. If the pins are in the in the board, you can like look kind of sideways and see if they're actually connected. Oh, it actually has a part number in there. It says 6NC05 C4 MCU.
Cool.
Microcontroller unit. So that does have a part number on there. S something NC05C4.
Not on there?
Not on there. Is it on the bottom? Bottom A? Nope. Oh. S2564 US? No. Huh. So yeah, those are NCs. So with what I got, that's pretty much enough to actually do it. There's just a few other minor things to figure out. Like this is pin 4 is lockout, fail I'll call it. Pin 9. That's the reset that normally would connect to the CPU. So that's that. If you were to pull pin 4 high all the time, it would think every slot had a cartridge in it.
Interesting.
We can test that theory. So pin 3, I don't think pin 3 hooks up anywhere. I think pin 3 is an NC. See, this is where a logic probe would be really helpful because you could just stick it on there and see if that was a high or a low, you know, when it was running. You could actually watch it go through its sequence. For something like this, it would be perfect. So, are we 21, 2, 3, 4, 5, 6, 7, 25, 6, 7, and 8. Go all the way the hell over here. 25, 6, 7, and 8 are doing something. 1, 2, 3, 4, 5. Because they run all the way over here. 25, 26, 27, 28. They're going to the. Ones, 1 plus 3 nines. They're going to the PAL. No, I'm going to the PAL. So there's that. Buffer, latch, buffer, 04. So that's the PPU section right there. So I'm not sure what these are doing. They may not do anything. Oh, hey, there's a 393 here. Hey, that's really very interesting. I didn't see these 670s and that 393. A 393 is a dual 4-bit counter, and these are a 4x4 register file. So obviously Nintendo had some thing they were going to do on here, and they never did. probably storing some kind of options on there. So, yeah, I don't know what these are doing. So I guess the easy way to find out what they're doing. Oh, they're going, oh, that's dealing with this stuff. Okay. Very interesting. Really? Really? Why are they doing that? In any event, doesn't matter, it's an unstuffed option. That is, that allows them, that's putting a little bit of RAM up there. That's what those are. Those are little RAM chips. And then there's a counter for some reason. Oh, I bet the counter counts through those, them RAM chips. The address lines. Man, that's ghetto. Oh. Yeah. Yep. Yep, and these will go to a different pin. Yep. Yep. Okay. Yep, I see what they're doing. Those are the address lines. Don't know why they're doing that, but then again, I'm not Nintendo, so I can't tell you why they're doing that. So basically what this is doing here, this allows the CPU to write commands into these RAM chips, and then this will pick them up. It was for some kind of option that they never did. So those don't do anything. 670 NC. Well, that's interesting. Learned something. 40, 39, 38, 37, 36, 5, 4, 3, 2, 1, 30, 29. I think those are all NCs. Yep. So I'm going to say clock is coming in on 38 or 39. 39. Clock's coming in on 39. Right there, yeah. Yep, 4 megahertz clock.
Sweet.
That's it. That's how it works. So yeah, theoretically, I'll have to look at this, but games that use registers at 6,000 probably are not going to work. So if the game uses anything at 6,000 or below 8,000 hex, it will not work. So this includes games with save game RAM, MMC5. That gimmick cart won't work. So I guess we can test the theory, huh?
Yeah.
So theoretically, Super Mario Brothers 2 should work, but 3 will not. If I had to guess. I was reading somewhere that Nintendo phased these out because they wouldn't run the newer games. I don't want to push on that. There we go. Let me keep this out of there. So yeah, I'm guessing any newer game probably will not work on this if it uses anything below 8,000 hex. The Famicom box had the same problem. So what Nintendo did to kind of make some games work, they put the save game RAM on the main board. That's what they did. Oh yeah, these are those connectors that I like. Those Molex ones. That's a cute little switching power supply there. Made in India. Really? That power supply is kind of scary. Huh, that's interesting. This was originally wired for 220 volts. There's a jumper to select 110 and 220 on there. It must have originally been wired for 220 and then they changed it. I got a little ASIC for the controller, that's surprising. I guess it was 87, so maybe about right. That's funny. Doesn't even use a FET. It's got a regular old transistor for the chopper on there. Old school. Very old school. This thing output 5 volts and then probably 12. A couple voltages on there. Cause you checked the caps and they were all good, weren't they?
Yeah.
On there. I wonder why they had such a massive power supply for this thing. It was hand soldered too. Huh. Yeah, they hand soldered this thing. Or at least partially. You can tell they hand soldered it because there's no solder on these big exposed routes.
Right.
Oh, here it is. -12, +12, and 5 volts. Okay. That answers that question. Was one of those missing?
I got it.
No, I was wondering because I just saw some. Or do they all have lock washers? I thought one of them didn't have it. Okay. Oh. That's interesting. Need that part.
You gotta work in the morning?
Yeah, what time is it? 10:41. Yeah, I should probably leave around 11. Are you usually up all night, or you go to bed early?
I go to bed about 2, 3 a.m.
Oh, yeah, that's about me. I don't know if I'd be plugging that in like that. There's a... There we go. Yeah. That's better. There we go. There's going to be 340 volts on the power supply.
I think I felt it one day.
Did you feel it one time? Yeah, I would be real...
Unfortunately, it went up one arm and down the other.
Mhm.
It scared the shit out of me.
Yeah, those things, you don't fuck around with switching power supplies like that. Is that supposed to be purple like that?
Oh, look at that!
Is it working or is it all screwed up?
Looks right to me.
Okay. Well, Zelda will run without the WRAM. I'm sure the WRAM probably will work.
That wasn't me.
Yeah, what I think probably will happen is, my theory is, if you have multiple games that use WRAM and you plug them into this, it will corrupt some of them. You know what I mean? Because this, and this are all going to be enabled at the same time when it's writing, so theoretically it looks like it does work, but I'd be worried that it's going to corrupt your save game. You know what I mean?
Right. So... what else would I have that you want to try?
Yeah, do you have anything? Do you have Mario 3 on cartridge? I know that uses it.
I think that's...
Let's see.
It's either Earthbound Zero or Mario Adventure.
This isn't. Oh yeah. Guess we could try it. So it might. Let's see here. So that's 9, 5, and 9. So here's my theory.
You have to hold it for a second.
Oh yeah. Oh, you have to hold it.
Yeah.
Oh, there it goes. Okay. So that's 5. So we need to put 2 cartridges on the top row that have save games on them. So we'll put one in 1 here. So what are we? 1, 5, and 9. So 1 and 9 are going to be the 2 with save games. So got a controller. So here's the theory. So yeah, you got a game in there already.
Yep. So
now play game 9. It's funny, there's multiples of the... That can't be game 9.
It is.
It's Tetris?
Tetris Zero.
Oh, what's the difference? Oh, that's not going to work. It's got to use that
I don't
double...
think it even works anyway.
Oh, you don't think it works?
Well...
Well,
yeah.
Tetris is a MMC1 game.
Tetris Zero is
Oh, they
a
changed it.
combination of regular Tetris, or it makes original Tetris
Uh-huh.
2-player, or
Hmm.
there's
Okay.
something like that.
Oh, okay. I don't know. I'm not up on the homebrew
I never
stuff a
did get
whole
it to
lot.
work.
I think it's MMC1 unless they change it to MMC3, which is very possible.
So 10 was another result outlines and it didn't work.
Which one's that?
1.
1. Here, I got a theory. This should do it. Where's another one of those Zelda Outland carts that works? Which is the other one that works? Was it 4? Here's the theory. This will be a good test. Both games, after we play one of these, the other one should have the same save game on it.
They already do.
Here. Let's see. Okay. Game. That's funny. It goes to game 0 there for a second.
Yeah.
So. Here, I'll create a second one. Okay. So I got another player, so it works. Now we'll select game 5 and see.
Wiped it.
Now it's gone. See? So now if I create one here, okay. Now let's select game 1 again. See? There's now this one's working. Looks like. Okay. No, it does appear to work. Maybe they are controlling A14 too. Because it does seem to function. Weird. Doesn't mirror that kind of purple instead of white.
Are we in 30-second mode or something here? No, we're unplugged.
We're
We
unplugged.
should be in 128 mode.
Weird. In any event, it'd probably take a little more poking around to figure it out exactly what they're doing on there. But it does appear to save the 2 games at least. So I'm kind of surprised at that.
Maybe that one's just dirty.
Maybe it's just dirty. Oh, you know what? I bet if the lockout chip resets, it goes to the next game. You know what I mean? So, yeah, because it will not let you select a game that doesn't exist, will it?
No.
Well, I guess there it did.
No, there's a one in there.
Oh, there's one. Oh, that's the one that
It's
doesn't
just
work.
not loading for some
Oh,
reason.
okay. So here's my theory. If you pull that high, pin 4, if you pull pin 4 high, it theoretically would stop on every cartridge, I would think. Where's that clip lead at? Oh, you got a whole array of clip leads. The clip lead array. Yeah. Now try select another game.
Yep.
Stays on there, doesn't it?
Yep.
Watch. Watch when I take my finger. Watch when I take the probe off.
Yep.
Yep. So
As
that's.
expected.
Mm-hmm.
Nice.
Yep. So that's how you can leave it on there. So, but yeah, I wonder if I had my logic probe, I could poke it a bit more to see how it's doing that timeout. But I'm sure it's in this ASIC somehow. They probably just have a counter in there. But this is definitely enough information to make a small add-on board that you could plug in there in place of that chip to make it work how you want it to work.
So we're still just looking at which pin was it to put it in indefinite mode?
Well, you would have to pull the reset line off, which is it's on the latch. It's bit 5 of the latch. This chip here, which would be 1987. Pin 16 of this chip is where the reset comes out and goes into here. So what you could do, you'd break the connection between here and here. I probably would not lift the pin on here because it's probably the PPU and CPU are probably connected together, the reset lines, because they both have one. I didn't like that.
That weak socket.
Yep. Yeah, I found when you plug one of those headers in these sockets, it damages them somehow. It bends them out.
It's probably 3 times as wide as any chip leg that was going
Yeah,
to
yeah, exactly. there's your answer right there.
You can do that. It's done.
Yeah, when I was making the copy NES boards, I had a socketed NES and I would test each one, and that NES would not work with anything but a copy NES board because of that. I ended up getting a hold of the better headers like those RGB boards had, but I had to order like 60 or 80 of them at a time.
I've got a whole range of them, but those are too thin to stay, or they're too short to get down into the dual wipes.
Yeah, yeah. Yeah, it's hard finding a good thing that's compatible with it. That's pretty cool. Yeah, I'm just very surprised that they did that. They have that ASIC there. I mean, it just doesn't make a whole lot of sense, other than for security reasons. I don't know,
Those
maybe
other 2 numbers, like on the bottom of the chip and on the PCB, aren't going to mean nothing.
they don't mean anything. Mm-mm. All the other parts mean something, but those don't. Or those 2 numbers don't really mean a whole lot. I don't know, maybe it was designed in the US because they did use an RCA part. You think if it was designed in Japan, they would use a Japanese part.
Right.
You know, like the lockout chip's a Rico part, I believe it is.
Here's your track mode right here.
Mm-hmm.
Plays the intro of a game for a while, and then goes back to that.
Go to the next one until you hit the
part.
button. Mm-hmm. Well, the good news is the NES side doesn't have any special code that does any of the selection. It's all done through this chip, so that's the brains of all the game selection. That must be that game that doesn't work.
It used to. I don't know why it's not now.
Maybe it's just it's this one, right?
No, it's not.
Oh no, it's this one.
There you go.
That is dirty.
No.
Oh, that's weird. Yeah, I saw this down here, so I didn't know if that was normal or not.
For some reason, it is. Ew.
Junk on it.
Film, maybe from my degreaser.
Oh.
Loaded that time.
Okay. What you expected is it was made in '87, so it's old enough to smoke and vote and drink. Yeah, I was kind of surprised that they had a custom modulator in there like that. Is this the original?
Mm-hmm.
Yeah, you can't imagine they made a whole lot of these. This is 12493, but I highly doubt they made 12,000 of those.
Right. I don't know if they were put into every Walmart,
True.
but you think we would see more of them aftermarket. I mean, I
Yeah.
know they were probably supposed to be destroyed, but
No,
we
some
still
of
see a
them
lot
made
more
it
than
out.
we do.
Yeah.
I mean, even sharp NES TVs.
Yeah, those are pretty damn rare.
Yeah, and we know over 100 of those, so.
Yeah, I thought those used RGB PPU, but they just don't, do they? They just use a
I
regular
haven't
old...
been in one yet, but I'm pretty sure it does not.
Mm-hmm.
Yes, they're both still sitting right here. I've got 2 of them.
Yeah, the legs broken on both of them.
Oh yeah. People are screaming for me to open the things up. They love that thing. I still got a Titler sitting over here too.
Oh, Tyler thing. Yeah.
Titler?
Titler.
That's like cool.
Yeah, I know that one has an RGB PPU in it because people were stealing them out of there to make the mods, I heard.
Probably less so on that console. I mean,
Yeah, it's worth a lot more.
It's still like $1,000 console.
Wow.
Yeah.
Yeah, I sold my Famicom box. The guy paid me like $900 for it.
There's one on eBay right now for $2,000.
Mm-hmm. I probably could have got more, but I just wanted to get rid of it. I was cleaning up, so. And I haven't used it in probably 5 years, so I mean, it's just sitting there.
Learned all you could. So.
Yeah, I reverse engineered it, and I mean, what else can you do? I wonder why the graphics are all screwy on that. Oh, probably the PPU.
Probably.
One of the address lines, I bet. Please look up the README. I don't see it up there.
Oh, I was like, what? And I forgot it was just Outlands, so yeah, it's an online README.
Yeah. Well, the normal game says, please look up the manual. And I'm like, oh, okay. Yeah, I know on Zelda, if you don't have the WRAM working, the whole intro works, and it gets about halfway through scrolling this and it just crashes. Which is kind of strange. You think it'd either work or it wouldn't, but you know. And then just like in the middle of scrolling, it just like, just dies. Pretty cool.
Well, we've got 2.5 weeks to play with it, if you want to.
Mm-hmm.
I mean, I don't have to sell it right away once I get the adapter board.
But you want to do, yeah. So, so you made a custom one to fit
I
that?
had to.
Oh.
It wouldn't fit vertically between the the bracket
that
that holds the power
shelf,
supply
uh-huh.
up, and also for the RF modulator.
Oh, yeah. It's got a... Oh, it has an E-Rev CPU in here. Wonder why. Instead of the G-Rev. It's got a G-Rev PPU though.
Does that mean anything to you?
Well, the Famicom box had a E-Rev CPU in there also. I don't know what the difference is. There's also an H. The Famicom usually is the only place you'd see an E or an earlier, but I don't know. Sometimes they do show up, I guess. I've never actually seen one in a front loader, though. Those have always been like a G or an H. The H's show up in the top loaders. Yeah, those are both G's on that. So what do you edit your videos with?
Power Director.
Oh, I've never heard of it.
I already forget who makes it. See, Sony does a Vegas.
They do Vegas. I've used Vegas.
Yeah. I want to say I was. Of course, I started with what everybody starts with, is the Windows Movie Maker.
Yeah, I've used that. Yeah, piece
Lame.
of crap. Basically, my video editing involves, I used, I have to convert it to RAW, and then I use, whatever the hell that program is. Virtual Dub. Open source thing. And all it lets you do is just cut it up. You can't do transitions, can't do titling, nothing. That's why my videos are so plain.
It took me a minute to learn Power Director, but now that I know it,
It's pretty easy.
oh, I love it.
Yeah, that was one part of the problem, camera editing. That's basically what's been stopping me from doing any better videos. I'd like to do some videos where maybe I assemble something or test something or do a tear down.
Yeah.
But
You
I
can't do the video speed thing either, can you?
The what?
Speed up the video?
No, I can't do anything.
Mm-hmm.
See, someone said I should, when I make one of these FPGA consoles, I should set the camera up and record it and do a time lapse of me actually testing it and writing it and all that.
It's easy to do in Power Director.
Oh yeah.
Mm-hmm. I'm sure it's easy to do in a lot of the bigger programs. You know.
Yeah, so just set up a webcam, you know, capture a frame every couple seconds or whatever, and just
I don't know.
throw it all in sequence.
Guaranteed to get somebody says, "Oh, where's the Benny Hill music?" Every time, man. Because I do a lot of video like that where I'm just not talking and doing something.
Yeah, you're doing something.
You don't need to see it in normal motion, so I speed it up. And,
Oh, definitely.
and every time somebody has to bring it up, I'm like, great. I don't have the rights to it though.
You watch that Mike's Electric Stuff Guys videos? I'm sure you watch those.
Actually, no.
Oh, you don't?
I really only watch Dave, and of course there's some car guys that I watch.
You watch that, what was that? Aussie 50? Oh, you don't watch that? You probably like that.
I mean, even though I'm on YouTube, I'm only subscribed to Dave.
Oh, yeah?
You know, because in the beginning it was like, hey, I see you're new on YouTube, why don't you subscribe to me and I'll return the favor. You know what I mean? I don't want to do that. You know, I want to be the guy that has all subs because they wanted to see my stuff. You know?
Yeah. Oh, I don't subscribe because people ask me to either. I just see you're on there. Obviously, Dave is that Mike Electric Stuff guy. You probably like that. He does teardown. He does kind of like the stuff Dave does, only a little higher brow. You know, like he's like today he tore apart one of those FLIR cameras.
Ooh.
That was really cool.
Thermal camera?
Yes.
It wasn't the...
It goes onto an iPhone. It plugs on the back of an iPhone. A FLIR camera.
Really?
Yes. It was really cool. Yeah, you probably like that. Yeah, he does a lot of really... You know, Dave does a lot of the general teardowns. Oh, here's a computer. You know, here's an old computer. Here's a calculator, a stereo, oscilloscope. And the Mike guy, he tore apart a baggage X-ray scanner from an airport. That was really cool. I was very surprised at that.
I have to say, I haven't really watched a lot of Dave lately. It was all the old stuff that I liked. Of course, he gets into the real technical stuff.
Yeah. I fast forward through a lot of his video. You know, I use judicious fast forwards. I mean, yeah, it's okay. I mean, I know you gotta help the newbies, but yeah, I don't need to hear you talk about 20 minutes about a data sheet that I already know. So it's like he opens up the data sheet. Oh yeah, this is power supply chip. You know, blah 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 blah. And here's the data sheet for it. It's a Bobby Dazzler. I love that. It's a thing of beauty and a joy forever.
You see the what do they call that? The speaking voice or what is it called?
Yeah, I saw that.
That was hilarious.
Yeah.
What's funny is I seen it on Ben Hex before I seen it.
Yeah, I did too.
It was awesome.
I think that guy needs to lay off the hot melt.
Which guy?
Ben Hex. I don't know if he uses so much anymore. He used to.
I've only watched a few of his. He did the one where he did the VCR loading front loader.
Okay.
Where it pulled the cartridge in.
Okay.
And he pulled out a Radio Shack desoldering iron. And I said,
one with the squeeze bulb on it?
Ugh. I mean, I did a whole video about desoldering tools, and that's the one thing I left out. I wish I had it in there. Because
yeah, you should have.
It was
it's like, don't use this.
I had it for a while, and it worked better than some, and it was a good starter tool.
Yes, exactly. It's a good start. You know? If you want to take out one CPU, it's okay for that.
Right, exactly.
But if you want to do it more than once, get a real tool. What do you have? You have an 808? Yeah. At work, we have one, and I just borrow it.
Yeah.
Take a board into work, just go, call it the angry duck. That's what it sounds like. I don't have an 808 at work, but it sounds the same and it looks very similar. It's a Denon, like 3000. We've had it, 18 or 20 years now.
Wow.
And I keep fixing, the parts are pretty cheap, so, there's wear items, like, have you ever taken yours apart to clean it? Yeah, you got to clean the diaphragm out and the valves and all that, because it gets the flux on there and it just sticks and doesn't work.
You don't have a fiberglass filter before all that?
It does.
It does?
It's got a felt filter, and then it's got a cigarette filter, a fiberglass cigarette filter. And it's literally a cigarette filter. When they come from the factory, it has the paper around it and everything.
Interesting.
Yeah. So we got some cigarette tubes at work the guy brought in. You have the empty ones, and we just cut the filter in half and stick it in there, and it works great. But yeah, I have to do that about once a year. You take it all apart, clean the flux out, some alcohol, and put it back together, and it works like brand new. I think I've changed the diaphragm twice, the valves 3 times. The valve's just a little piece of rubber with flaps on it. It's real simple.
Yeah.
Change the temp controller board, change the element, and you've probably been through about 15 tips or wear items. So, I mean, man, that thing paid for itself the first week we had it, though.
Oh, I agree.
Yeah, before that I was using the desoldering pump where you press the button and it goes, oh, those things suck.
Yeah, I still have one up there for just for one-off stuff.
Oh, yeah.
Not worth waiting for the to heat up, you know.
And those multi-layer boards, trying to take a dip chip off one of those really sucks.
I bet.
You know, without that thing's awesome.
Yeah.
Just comes right off. So yeah.
It was a big topic on the NES RGB thread.
Oh, was it?
On Shmubs, everybody was crying about trying to get CPU or the PPU out of the board
without breaking it and being able to reuse it.
Yeah. There needs to be another one of those community items where they pass it around person to person after they're done, but it's only like $150, $200 item.
Yeah, it's not that expensive, really.
You can probably buy one used, use it for a month or two,
and then
resell
sell
for
it.
the exact same amount of money.
Yeah, it's really hard. Some things, it's kind of funny, some things seem to really hold their value, and it's hard to get a good deal on it. Fluke meters, for example. So I do like this. I'm going to have to, I'll think about getting one of these. What is this? This is a U1272A. I'll write that in here so I don't forget. U1272A. It's kind of chunkier than I was expecting, though.
Agreed.
Oh, it's got 4 triple A's in it. Oh, that's interesting. How long do those last?
I don't use it enough to make them go
Oh,
dead
okay.
yet. It is just a little bit bigger than I would have preferred, but
Well, it's not like a scope meter, you know, the Fluke scope meter. Have you ever seen one of those? It's like literally like this big.
Yeah.
It's funny. I remember seeing the ads for it back when it came out, and they show some guy holding on. It looks just like a regular. It looks like this. You're like, oh yeah, oh that's really cool. And you see it in real life, it's like literally like this big. I mean, it's like the biggest thing ever, and it's like I wonder whose guy's hand that is holding on to that thing. Yep. Hard to beat a good meter. Oh well, I guess I didn't have to bring my programmer stuff because that turned out not to be a micro, but oh well. I'm still wondering why they have that latch on there. I wonder maybe if they screwed something up or something. I don't know. It would be neat to see what was in there. Too bad there's no way to find out what's in that thing without peeling it and looking.
right. We ain't doing that.
Nope. It's not worth it. In any event, it looks pretty easy to make a clone of what it does, at least.
Definitely an interesting item.
I don't know what you could sell that for, though. That kind of mod. I wonder what you could sell it for.
You mean just me doing it?
Well, just anybody selling just a replacement board that you can just plug in that anybody could plug in.
Oh, I see what you're saying.
Because you can make a little circuit board that plugs in there. You put a microcontroller
Well, and
on
you're
it.
talking about a very slim audience.
Yeah, there's probably, what, 20 people that have one of these things?
Exactly. It'd be a labor of love more than anything, that's for sure.
Yeah. Well, I gotta get going.
Right on.
Yeah, well, that was